All right, let's jump straight into the action. We're going to walk through a super realistic cybersecurity internship project step by step. Think of this as your very first mission inside a Security Operations Center, or SOC. Your goal? To build an automated tool to stop an attack that's happening right now. So let's set the scene. It's your first week as an intern. You're just getting your bearings and boom, alarms start blaring. The system is getting hammered with brute force login attempts. And at the exact same time, phishing emails are landing in everyone's inboxes. The pressure is on big time.
Your new SOC manager turns to you. They're not asking you to watch from the sidelines. They're asking you to get in the game and build something. So here it is. Your mission, should you choose to accept it, is to create an automated tool that will help the team find, validate, and respond to these threats. This is where the real work begins.
Okay, so before any mission, what do you need to do? You gotta gear up. Every hero needs the right tool, right? Well, in the modern SOC, that tool, your superpower, is Python. It's the engine that's driving pretty much all the automation, analysis, and rapid response in cybersecurity today. Now this is such a critical idea to get your head around. Automation isn't about getting rid of the humans in the chair. Not at all. It's about empowering them. A security analyst who knows how to use Python can investigate threats and tear through massive log files in seconds, not hours. It's a total force multiplier. So why Python? I mean, why this language specifically? Well, for starters, it's lightweight and it runs on pretty much anything. Second, it has this massive ecosystem of specialized cybersecurity libraries, so you're not building everything from scratch. And maybe most importantly, it's an absolute dream for connecting to APIs, which lets you pull data from all your other security tools. It's just perfect for building and testing new defenses on the fly. And here's just a little taste of that arsenal. I mean, look at this. There are tools for pretty much everything you can imagine. For our mission today, we're going to be living in that threat intelligence category, using libraries like requests to talk to APIs. And in log analysis, something like Pandas is an absolute game changer. It's built to handle huge amounts of data way better than you ever could with just basic Python. Okay, theory's over. It is time to start building. We're going to put together a 3-part toolkit that's going to help us fight back against this attack. This right here is the heart of your internship project. So our mission breaks down into 3 very clear phases. First, we hunt for clues. These are called indicators of compromise, or IOCs. Second, we validate those clues against what the global security community knows. Are they known bad guys? And third, we report our findings clearly so the team can actually do something about it. Hunt, validate, report. Each step builds right on top of the last one. Step 1 is all about digital detective work. Your first script is going to be an IOC scanner. Think of it like a bloodhound. Its only job is to sniff through mountains of log files, web server logs, email logs, you name it, and hunt for those suspicious patterns. It's looking for the breadcrumbs that attackers leave behind, malicious IP addresses, shady domains, or known malware file hashes. Okay, so now we've got a list of suspects, right? But are they really bad guys? That's where step 2 comes in. Your second script will use a threat intelligence API, like the one from VirusTotal. Now, don't let the name API scare you. It's basically just a way for our script to call up an expert service and ask it a question. For every single IP our first script found, this one asks, hey, has the world seen this thing before and is it malicious? This is how we turn a simple suspicion into real actionable intelligence. Look, all that amazing intelligence is totally useless if you can't communicate it clearly. And that's the whole point of our final script. It takes all your findings, the IOCs you found, and the intel you gathered, and it packages them into a clean, easy-to-read report. It'll even flag the really high-risk stuff so the SOC team knows exactly where to focus their energy first. Now, you might be sitting there thinking, okay, this is a great internship project, but is this what the pros really do? And the answer is a huge resounding yes. The principles you're learning right here are the absolute foundation of how modern security operations work at the world's biggest companies. I mean, seriously, this stuff is everywhere. You've got Google using Python-driven automation to isolate a compromised machine in less than a minute. A minute. CrowdStrike uses it to coordinate responses in the cloud. Tools you use every day like Splunk rely on Python for custom alerts, and national cyber response teams use these exact techniques to hunt for threats on a massive scale. The skills you're building here are directly transferable to the real world. And now for the final stage of any project, the evaluation. How would a SOC manager actually grade your work? Because, trust me, it's not just about whether or not the code runs without errors.
Now, what's really interesting here is the breakdown. Yes, having accurate code is worth 25% of your grade, but look at this. So is the quality of your threat intel integration. And your reporting quality and how well you can explain your workflow make up another huge chunk. The big takeaway here is that success isn't just about writing a script. It's about building a complete, logical, and effective security solution.
So, we've built the tool, we've seen how it's used in the wild, and we know how you'd be graded on it. But this all leads us to a final, really critical debrief, a core question about the future of security work itself. And this is the question I really want to leave you with. Automation gives us incredible speed and scale for all the threats we already know about. But what about the brand new attack? The one that doesn't fit a pre-written rule, the one a creative attacker designed specifically to slip past the bots. That's where a seasoned human analyst's intuition, that gut feeling, is absolutely irreplaceable. The ideal model, of course, is a hybrid, where automation handles the grunt work, freeing up human experts to hunt for the unknown. But finding that perfect balance? Well, that's the ongoing mission for every single security team in the world. What do you think is the right mix?